Hello everyone, welcome back in Skolarhive. So in this video we are going to start the basics of algebra. So in this basic of algebra we are going to deal with the ratio and proportions, polynomials, algebraic expressions and identities, and at last we'll discuss the direct and inverse proportion. So let me start with the ratio and proportion first. So ratio and proportion. So basically the ratio is defined as the comparison of two quantities of similar type, or the two quantities which is expressed in a same unit, that we can compare in terms of like how big one is as compared to other, or how small the second one as compared to first one. For example, in a class of 30 students, there are 20 boys and 10 girls. It means that for every 2 boys we have 1 girls in the class. So this is indicating the strength of boys as compared to girls. So ratio, if I'm writing like we have two quantity, let's say A and B, then the ratio of this A and B is written as A and B is written as A colon B, or we can write it as A over B as well. So here this we can read it as A is to B. So in a ratio we can find that we have two terms. This is A is one of the term, B is another term. So in that A ratio B, this first term we call it as antecedents, and the second term we call it as consequent. The first one we call as antecedents and the second one we call as consequents. For example, let's say we have given a, like in a class we have number of boys is equal to, let's say, 100, and girls is equal to, let's say, 60. If we want to find the ratio of boys to girls, it means we can write it as boy is to girls as 100 is to 60. It means this is nothing but 100 over 60, and we can simplify this by cancelling both numerator and denominator by the common factors. So we can find that 0 is going cancel by 0, so we left with 10 over 6, which is nothing but again cancel by 2, so this is 5 by 3, so which is equal to 5 ratio 3. So here we just have to understand we are using these ratios to compare two things of similar kinds, or the things which is expressed in the same units. For example, let's say we have given a man complete, let's say man A complete a job in 2 hours, and a man B complete the same job in, let's say, 90 minutes. If I'm asking to write the ratios of the time taken by man A and man B to complete the job, then you can find that the two things like this both are time, but they are not written in the same unit. So we cannot express them in ratio unless we are converting both of them in the same ratio. If you are writing this like man A ratio man B as 2 ratio 90, means this is not correct, because this 2 is in hours and this 90 is in minutes. So these are both are in different units, so we cannot express them in terms of ratio. So what we can do is, instead of writing 2 hours, we can write it as 120 minutes. Now we can find that both of these are written in a same units, so we can express this in the form of ratio as 120 ratio 90. And further we can simplify this in a like simplest form by cancelling by the common factor. So we can find that the common factor is 30, so 4 ratio 3 is the ratio of man A to man B. So I hope this is clear. Okay. Now let's move to the next. Combined ratio. Combined ratio. Suppose we have given different ratios as A ratio B and B ratio C, then we can combinedly write it as A ratio B ratio C. For example, we have given A ratio B is equal to 2 ratio 3 and B ratio C is given as 12 ratio 5. Then in order to write this A ratio B and B ratio C as a combined ratio, we just have to identify the B over here as well as here. You can find that the A ratio B is 2 ratio 3. It means the B part is 3. Over here the B part is 12. So in order to write this in the combined ratio, what we can do is, in the second ratio B ratio 3, we will try to make this part equal to this one. So for that what we can do is, we can simply multiply both antecedent and consequent of the second ratio by the this number divided by this second number. Okay, the B values of the first ratio divided by the B value of the second ratio, that we need to multiply with both antecedent and consequent. So as you can see, Over here this is 3 and this is 12, so we just multiply by 3 by 12 in the antecedent as well as in the consequent also, 3 over 12. So once you simplify this, you will get it as this is as 3 and this as 5 by 4, because this 3 is going to cancel this 12 by 4, so this is 5 by 4. So we got this ratio B ratio C as 3 ratio 5, and here we have B ratio C as 2 ratio 3. So combinedly we can write this as A ratio B ratio C as 2 ratio, here 3, here also 3, so 2 ratio 3 ratio 5 by 4. So this is the combined ratios of these two different ratio, A ratio B and B ratio C. Now we can learn some of the properties to deal this kind of, like if we are getting some fractions or decimals in the ratios, to convert that into the ratios of our integers. So over here we can find it like A ratio B ratio C. In the first two, this is integer, this is also integer, but this is not integer. This is not integer, right? So in such a case, we have to understand one of the thing, like if we have given the ratio of two quantities and that ratio are both, I mean both of the quantities are integer. Let's say here we have ratio A ratio B, in which A and B both are integers. A and B both are integers. Then we call it as commensurate. Commensurate. If any one of these in the ratios is not an integer, then we call it as incommensurate. Okay, so here as in this case, we'll learn this under the properties of ratios, how we can convert this incommensurate into the commensurate form. Okay, so let's say we are talking about the properties of ratios. For example, I have given a ratio as 12 ratio 3. 12 ratio 3. So here this we can write equivalently as, like we can find that in a antecedent and consequent we have common factor as 3. So we can get this ratio by dividing by the common factors of both antecedent and consequent. That is going to give us 4 ratio 1. So here, as we can find that in an antecedent and consequent we have a common factor other than 1, so we can see that this ratio is not in a simplest form. So what we can do is, like we just have to divide both the antecedent and consequent by their common factor to get the corresponding simplest form of the ratio. Here we got the 4 and ratio 1. Here 4 and 1 is having only the common factor as 1. So this is what we mean the simplest form. Simplest form. Simplest form means what? There is no common factor, means HCF, we can say simply HCF of antecedent and consequent is 1 and consequent is 1. As here we can find the HCF of 4 and 1 is 1, it means this is in the simplest form. But here, as in this case 12 ratio 3, the common factor for both 12 and 3 is 3, so the HCF is, as in this case is 3 is not 1, right? So this is not in the simplest form. Now when we divided both antecedent and consequent, this is just the equivalent form of this ratio 12 ratio 3. So we can get the ratio by multiplying and dividing by some non-zero real number as in this case I have divided both of them by 3. So we can find that this is very important property that we have. If we have given ratio, let's say A ratio B, if we have A ratio B, it means that will be equal to M A ratio MB, as well as we can say that here M is non-zero real number. So real number is nothing but rational number as well as irrational number. Okay, we can write this as A ratio B as A over M ratio B over M. The same thing over here, M is non-zero real number. So as we are writing the ratios in their corresponding equivalent form by multiplying by non-zero number and dividing by non-zero number, so these two are the equivalent form of A ratio B. And if we have, as in this case we have seen that 12 ratio 3 is not in the simplest form, as the HCF of these two number is not 1. So to make it into the simplest form, we can divide both of them by the common factor, that is going to give us 4 ratio 1. So actually what we are doing is we are trying to find their corresponding equivalent form. Okay, now one more thing we can just remember, like if we have given the A ratio B means two quantities ratios given, so this A ratio B and B ratio A is not the same thing. These two are completely different. These two are completely different. We can understand this as, let's say A is indicating the number of boys over here and B is indicating number of girls. So as I said, in a class of 30 students, we have 20 boys and 10 girls. If I'm asking you to write the ratios of boys to girls, so we'll get as boy ratio girl as 20 ratio 10, which is 2 ratio 1. So this is boy and this is girl. But if we are writing this girl ratio boy, then this will be 1 ratio 2. So these two, like 1 ratio 2, as here you can see that this 2 ratio 1 is again indicating the boys is to girls, but 1 ratio 2 is indicating girls is to boys. So these two are not same. These two are not same. So order in ratios matter. Order in ratios matter. Make, like, you should not like do like if 1 ratio 2 is there means this is same as 2 ratio 1. This is completely different. Okay, now suppose we have given a number n, and this number we want to divide into two parts in some given ratio. For example, I have given a wooden stick of 100 meter and I want it to divide into two parts, but in some ratios. I want to like divide into two parts. That might be one part over here is this much and this second part is this much, or might be this first part is this, second part is this. So like I'm telling that okay, one of the part is 2 and the second part is 7. I mean, I'm dividing this into 9 equal parts, in that the first part is containing the 2 out of total 9, and the second part is 7 out of total 9. So in such kind of questions, like we have given some number and we are dividing into 2 parts or 3 parts in some given ratios, then we can have to use this concept. Suppose let's say I'm taking that this is divided into 2 parts in the ratio A ratio B. Then this first part is equal to, see here, A ratio B means this is the first part, this is the second part. So if we are adding both of this, means that will give us the total part. Like I said, over here this is 2 part, this is 7 part. So 2 plus 7 is what? 9 part. So I'm dividing this into 9 equal parts. In that, the first one is 2 part and the second one is 7 part. So here, in this particular number, if I'm dividing in this ratio A ratio B, it means the first part of this is equal to what? The first one divided by the total, the sum of these two, A plus B, multiplied by what number we are dividing. So the number n we are going to divide, so we just have to multiply this. And the second part will be equal to the second part from here, and the total A plus B multiplied by the number we are going to divide. For example, I have 1,000 rupees. Let's say Rashid is having 1,000 rupees, and I'm dividing this 1,000 rupees into 2 of my student. Let's say student A and student B. I'm dividing this 1,000 rupees between student A and student B in ratio 2:3. It means out of the total 5, 2:3 means total we are dividing into 5 part. In that 2 part I'll give to A and 3 part I'll give to B. So how much does A will get and how much B will receive? So we can find that student A will receive how much? This, the first one is going to give to the A. So 2 over the sum of these two, 2 plus 3 is 5, multiplied by what amount I am sharing? 1,000 rupees I am going to share. So once you find this, this is going to cancel this by 2 times. So this is equal to 400. And the student B then will get the second share over total is 5 times of 1,000, that is going to give us 600. As I have taken the case of 2 part, if we are dividing any number into 3 part, let's say A ratio B ratio C, then in that case the first part will be A over, the total will be A plus B plus C, and the second part will be B over total means A plus B plus C, and the third part will be equal to C over A plus B plus C multiplied by the number we are going to divide. So this way we can divide the numbers among different groups in some particular ratios. So most of the time we'll get the question based on this in a case of shares. Okay. So now let's move to the some other properties of ratios and some more types of ratios. Okay. reciprocal ratio, or we call it as inverse ratio. Let's say we have given a ratio A ratio B, then its reciprocal ratio is obtained by taking the reciprocal of both antecedent and consequent. So we can write it as 1 over A ratio 1 over B. For example, we have given a ratio in terms of, let's say, 2 over 3, then its reciprocal ratio or inverse ratio, I'm writing IR for inverse ratio over here, is nothing but 1 over 2 ratio 1 over 3. If we are given like 2 over 5 ratio 3 over 4, and we want it to write in terms of, let's say, simple form, as you can find that this is not commensurate, right? As both are fractions. Commensurate means what? Both antecedent and consequent should be integers, right? As in this case, this is not integer. So we can make both of this as an integers by multiplying both antecedent and consequent by the LCM of the denominator over here. So here we have 5, here we have 4. The LCM of 5 and 4 is what? 20. So if we are multiplying both of this by 20, then we'll get the corresponding equivalent form, which is nothing but 5 4 times, 4 5 times. So this is 8 ratio 15. So this is the an equivalent form of this 2 over 5 ratio 3 over 4, which is 8 ratio 15. Let's see another type of ratio, compounded ratio. Compounded ratio. So if we have given two different ratios, let's say we have given A ratio B, and we have given C ratio D, and we have given E ratio F, like this we have given certain more ratios, then their compound ratio is obtained by multiplying their corresponding antecedent and the consequent. So the compound ratio is equal to what? Compound ratio is equal to the multiplications of the corresponding antecedents. So here antecedents are A, C and E. So this is A, C, E. Ratio consequent is B, D and F. So this is B, D, F. For example, we have given a ratio A ratio B is equal to 4 ratio 5 and B ratio C is equal to 3 ratio 4, then the compound ratio is given by compound ratio is equal to the product of antecedent, which is 4 multiplied 3, ratio product of consequent, which is 5 multiplied 4. Now you can find that in antecedent and consequent both are having 4 as a common factor, so we can just cancel the common factor. We'll get it as 3 ratio 5. Okay. So now we'll see, as we have seen, the ratio is said to be commensurate if antecedent and consequent both are integers. But what if both are not integers? For example, as we have seen, this A ratio B is commensurate, as we said, this is to be commensurate if A and B both integer, right? But what if we have A and B both are not integers, or one is integer, other is not integers, or both are non-integers. But we can able to convert that into the form of like integer form. Then that ratio we call as commensurate ratio or commensurable ratios. For example, we have given 1/2 ratio 3/5. As here 1/2 and 3/5 both are fraction, not integers, so this is not commensurate, but it is commensurable by converting this into antecedent and consequent both as a integers. So we can convert this into like integers as by taking the cross multiplication or by multiplying both by the LCM of the denominator of 2 and 5. If you are doing so, the LCM of 2 and 5 is 10, so multiplying both by 10, so 3/5 multiplied 10, we are going to get it as 5/6. It means this particular ratio 1/2/3/5 is commensurable. So commensurable means any ratio which can be converted into the form of like ratios in which both are integer. But in this case, as we can see, like we have given 2/3. So here 2 is integer, root 3 is not integer. It is not a rational number. Right, so there's no way that we can convert both of these to be an integer. So this ratio cannot be expressed in terms of the ratios of like both antecedent and consequent as an integer. So this kind of ratio we call as incommensurable. Okay, now let's talk about some more type of ratio. Like we have given a ratio A ratio B. So if we are taking a square of both this ratio, I mean antecedent and consequent, then we'll get another form of ratio that we call as duplicate ratio. So this means this is what? Duplicate. Duplicate of A ratio is B is nothing but A square ratio B square, means just we are like doubling this number, right? I mean we are taking the square of this as well as a square of this. And if we are taking the cube of this number, like cube of A as well as cube of B, then we'll get AQ ratio BQ, that we call as triplicate. And if we are taking, let's say, a square root of this A as well as B, so that will give us a square root A over a square root B, that we call as sub-duplicate. Likewise, we can write this as cube root of A ratio cube root of B, so we call it as sub-triplicate. Sub-duplicate means a square root of both antecedent and consequent. Sub-triplicate means what? Cube root of both antecedent and consequent. And triplicate means cube of antecedent, cube of consequent. Duplicate means a square of antecedent and a square of consequence. Okay, so I hope these things are clear. So let me just take one example over here. So for example, we have given like a question like this. If we are what is to be added to each term of the triplet of A ratio B to get equal to A ratio B. So we have given what things need to be added in the triplet of this so as to get the values equal to A raised to B. So triplicate means what? We just have to take the cube of both antecedent and consequence. So try to solve this. If you are getting the answer, that's very fine. Otherwise, you can just follow the solution over here. So as here it is like A is to be triplicate. In that we are adding something. What is to be added to the each terms of the triplet means triplet of this first. So triplet of A ratio B is what? Triplet of A ratio B is AQ BQ. Now in that what is to be added? What is to be added? So let's say I'm adding X in each term, so that we are getting a ratio A ratio B. So if you are just writing this in the form of fraction, then we will get as AQ x over BQ plus x is equal to A over B. Now just do the cross multiplications and write x in terms of other values. Then you will get it as AQ plus x multiplying by B means this B is going to multiply by this as well as this. So we'll get it as AQB plus bx, and on the right A is going to multiply by both of this, means we'll get it as ABQ plus AX. So try to bring like variable x as one place of equal to symbol. So let me just shift this ABQ in the left and this on the right. So AX minus of BX. In these two we can find that B is common. Then we left it as like if I'm taking AB common, here this is AQ means we're left with A square. As B taken common means once you multiply both of this means AB into A square means what? AQB. And then subtraction we have, as we have taken AB common, what is left? B square left is equal to X if I'm taking common means A minus B. Now further you might know about this identity. A square minus B square identity means this is A minus B multiplied by A plus B times of AB is equal to X times of A minus B. And you can find that A minus B and A minus B is going to cancel, means AB times of A plus B is equal to X. If we are adding this number AB times of A plus B to the triplet of the each terms of the triplet of A is to B to get back the result as A is to B. I hope it is clear. You just have to play with the like algebra, simplifications of algebraic expression by using the identities. We'll deal the identities in details in like the third or fourth lecture of this basic algebra series. We have seen the equivalent form of the ratio, means we have given A ratio B. I'm writing in the form of A by B, which is nothing but A ratio B, and we have given C ratio D. If both A ratio B and C ratio D are equal, it means what? A ratio B is same as C ratio D. A ratio B is what? Equal to C ratio D, means we can write it as A ratio B is same as C ratio D, right? So A is to B is same as C is to D. That we can write it as A ratio B proportional C ratio D. It means if we are having four numbers A, B, C, D, so we can call this number A, B, C, D is in proportion if the ratios of A, B equal to ratios of C, D. So whenever we have A ratio B proportional C ratio D, it means we'll always have to look into this, means the ratios of this equal to ratio of this two. So here we can call this as A, B, C, D are in proportion. So as these numbers are in proportions, it means this condition should be met, means ratios of first two equal to ratios of the last two. Now here we see we have four numbers A, B, C and D, then in order to check whether these numbers are in proportion or not, we just have to check the ratios of the first two and the ratios of the second two, whether both ratios are coming equal or not. There is another way of checking the proportionalities of the number. For example, we have given four numbers A, B, C and D. So out of this four term, let's say if I'm telling that okay, this two are, or let me just write it as, okay, I'm writing it as like we have given this four numbers in the ratio, A ratio B and proportional C ratio D, means if this is the proportional, right? So in that A, B, C and D all are terms. So out of these, the one which is like very extreme left and very extreme right, that we call as extreme term. This A and D are what? Extreme term. And which is in the middle, that we call as mean term. So if the number A ratio B proportional C ratio D, it means this is possible only if the product of extreme is equal to product of extreme equal to product of mean. It means A into D should be equal to B into C. Over here we have A, B, C and D. These four numbers are in proportion. These four numbers are in proportion. It means we have this AD is equal to BC, right? So out of these four numbers, this one we call as, the last one we call as the fourth proportion. We call it as fourth proportion. And this one we call as third proportion. So let's try to check whether a given number is in proportion or not. For example, we have given 6, 8, 3 and 4. Whether this number is in proportion or not, so we just have to check two things. We have the product of extreme, which is 6 and 4. So multiplied 4 is 24, and the multiplication of these two, mean is 8 multiplied 3 is 24. As both product of extreme and mean are equal, it means these numbers are in proportion. So are in proportion. Now let's say if we have given 3x, 7 and 27 are in proportion. Then what is the value of x? How we can find the value of x? As these are in proportion, it means we must have the product of ratio product of extreme equal to the product of mean. So we can find that. So 3 into 27 is equal to 7 into x. So it means this is 81 by 7 is the value of x. Right. Now over here, try to find this. Find the fourth proportion. Over here we have given 6, 4 and 8. Find the fourth proportion, and the given numbers are 6, 4 and 8. It means we have given first three numbers. As I said, the fourth proportion means in a four proportional we have given three numbers, means the third one, like fourth one is the last number, right? So in such a question we just have to deal with like the product of extreme is equal to product of mean, and then we can get it. So as the fourth proportional is missing, so we can consider the fourth proportion as x, and then we can use the product of extreme is equal to product of mean. So we can find that 6 into x, this is what product of extreme is equal to product of mean. So we can find that x is equal to 4 into 8 by 6. So upon cancellation we can get it as x is equal to 16 over 3. Let's try to solve one more question. Find the third proportion. Here we have given 5 and 15 and 75. We need to find the third proportion. So as it is mentioned that we have given this number and we need to find the third proportion, it means this is the first, second, and this is what? The fourth one. So we just have to take the third proportion just before this number. So let's say the number 5, 15 are the first two, and the third proportion is x, and then we have 75. Now we can use the product of extreme and product of mean to get the value of x. So here 15 into x is equal to 5 into 25, 75. Product of mean is equal to product of extreme. So x is then equal to 15 is going to cancel this 75 by 5 times. So this is x is equal to 5 times of 5 is 25. Okay. Now continued proportion. Let's say A, B, C are the number in continued proportion, It means that we have continuations of number. Okay, so here A ratio B, and then there is a continuation, so that then B ratio C. So A ratio B is equal to B ratio C. If A, B, C are in continued proportion, then we'll get A over B is equal to B over C. Or upon some simplification we can find that like A into C, B is equals to here, B into B is B square. So we can find that B square is equal to AC. In this continued proportion, the middle number we call it as mean term. The middle one we call it as mean term. So the three numbers A, B, C are said to be in continued proportion if the condition B square AC meet over there. So whenever we are finding such things in solving the problems, when we are getting the square of a number is equal to the product of 2, it means that the number which is the square is nothing but the mean term. So in this let's see, we have given find the third proportion. In this we have given 6, or let's say we have given 3 and 6. Only two numbers we have given, and we need to find the third proportion. It means only two numbers given and we need to find the third proportion. It means the numbers are in continued proportion, so we can consider that the third proportion be, let's say, x. Then we can just use the concept of the mean proportions or continued proportion, like product of extreme, I mean the product of the middle term, means the square of middle term is equal to product of first and last. So it means the 3 into x is equal to what? A square of this number. So this is nothing but 36. So 3 into x is 36, means x is equal to 36 by 3, which is equal to 12. So let's try to solve one more question based on this. Find mean proportion. Find mean proportion of 3 and 12. Only two numbers we have given, we need to find the mean proportion. Hence, we have given continued proportion, we just have to find the middle of these two numbers, right? So mean proportion means we just have to take the mean term as x. So it means 3, x and 12 are in continued proportion, so we can write it as product of extreme is equal to product of mean. So x square means x into x is equal to 3 into 12, which is 36. So x square is equal to 36, means x square is equal to 6. X square is equal to what? As over here we have a square, so that side goes to this 36, means a square goes to root plus minus of 36, which is going to give us plus minus of 6. Or if we want, we can just take the positive value of x. Okay, so I think these all things are clear. We'll discuss in the next videos regarding some more properties of ratios, and then we'll solve some. These all are basic questions. So the next videos will be based on some of the properties on on that most of the question will solve, which will be very interesting questions. So just try to follow the lecture, go through all the concepts and solve these questions. I will give the worksheet for this particular lecture 1 in the lecture 2 videos, and lecture 2 videos worksheet in the lecture 3 videos, like that. Okay, so one more thing I just want to discuss over here. Let's say I have taken a, b, c are in continued proportion. If we have, let's say, 4 numbers or 5 numbers are in continued proportion, then how we can deal that? So let's say we have given over here a, b, c, they are in continued proportion. If a, b, c and d are in continued proportion, then we'll find that the ratios of a and b equal to ratio of b and c equal to ratio of c and d. Like that, if we have 5 numbers, then this way it will continue. Okay, so just try to solve the questions based which all I discussed. Try to practice by yourself, and then in the next videos I'll keep the worksheet based on the lecture 1. If it is possible, I'll keep the worksheet in this lecture itself. If not, means I'll keep in the next lecture. So just follow the lecture, then you will find it you will learn the things in a proper way. So we'll meet in the next lecture.